Pretty cool shader. Ooh, okay. So, I know I said I wasn't gonna stream today, but I had an idea for how to debug one of the big bugs. My coffee machine didn't make that much coffee. I told it to make a full cup, and it did not. It kind of went at the end. It was only $50, so I don't know. Like, get a new one. Consumerism. I was saying when I got it, I could buy a new one every single day. Oh, oh, I can only make one cup of coffee. Okay, so what is the bug now? That is a good question. Bug 7 is not entirely that good of a description, is it? So once again, we're on the big old list of bugs. So this happened when the style was bugged. And so like the MV value is the gain value. So if I go into strafe, and we play Arcane, it's the value that controls how much to the side I go when I press D. So I'm going at this speed. This is the MV speed, and that controls how much you gain when you strafe. So the style was accidentally using like a microscopic MV value, like 1/1000th of a unit per second, something like that, and it would instantly make you fall through the ground. So that seems like a good opportunity to debug why you fall through the ground, because it's a very consistent reproduction of the issue. So if I'm trying to find out why you fall through the ground, I need to make the game make you fall through the ground and then check out why it does it. All right, I'm going to switch to funk, I think. Uh-oh. What funk are we on? That one. That one. I think it's more like later. Uh-oh, I didn't write down where we got to yesterday. Oh, maybe I was playing Shack Attack, actually. Yeah, I think I was. All right. Okay, so what I want to fix is the falling through the ground. I never experienced this, was also in Surf. So this is a standalone game that I'm making that's not on Roblox. So this is not Roblox. This is just my like game engine. It's an executable that just is the game, right? There's no engine. You don't need anything else. You can just play the game. I've been working on this for like a year. Or are you talking about that you've actually tried this before? I don't know the context. Yeah, it doesn't happen in Roblox. In the Roblox games. The Roblox games are a lot more safe about it, though. Like, in the Roblox games, I do correction. So, it does, like, duplicate checks, where, like, if you, like, clip into something, it, will go, oh, you're not supposed to be inside that, and then check again and stop you the second time. So you like are going like this, you haven't hit it yet. It doesn't figure out that you're touching it now, so you clip inside it. Oh no, it should be touching now, and then it starts touching. Whereas this standalone thing I made from scratch is it only has one chance to do the hit detection, and it doesn't ever second guess itself. It doesn't do any duplicate work. If it does the wrong calculation in the like millisecond that you touch it, it never checks again. So it's like more fragile, but also faster and does less work. Is this momentum mod? No, I made this from scratch. It's all my code. Well, using libraries, I guess. There's a wonderful library for reading Roblox map files, and then I can generate the polygons and physics objects and whatnot that exist in that map based on the Roblox map data. And that's what I'm doing here. Is it's based on Roblox maps right now. So I like wrote a mesh reader that like reads the meshes. I don't know why it's like that color, but yeah, it's fully custom. You can actually try it out if you want. Right here on the releases page. It's been a while since the last release. Can you comp Vastum Desertum? I think that's like a tough map, right? I would guess that I cannot. Let's see if I can do it in this thing. Let's see. bhop. Vast. All right. Is it converted? Do we have the map? Run map files. Maps. Bhop. All. That map. Ooh. Hold on. I can make the textures work. This one. Oh no, it's here. Yes. So rename to texture source. Rename this to textures. And that should have the textures. Nice. Oh, it's this map. Oh, that's not too hard. I probably won't get it first try, but let's see. And like not on an optimal line, of course. Oh, yeah. It's a wall. I hope all the boosters work and stuff. Looks good. Failed the challenge. Didn't get it first try. Oh dear. Wormhole. Oh. Oh. I'm not going for that. Hooray! Oh, that's not the end. I haven't played this map in a while. Nice. Uh-oh. Second try. I'll count it. No. I didn't get it first try. Let's see, what's my time? 78 seconds. Not that great, if I recall correctly. It also counts the exact nanosecond. Hey, is that 10 bits? Thanks. That's like 9? 9 bits. Thanks. All right. Now on Roblox. Yeah. Do I have a time on this map? Alright. We'll do it. I think I have a... map vest. It looks different. Makes sense. It's not the same, like, game engine. This one's not written from scratch. I mean, it is actually. No, it's not actually. This is based... Roblox is based off of the Ogre engine. Oh, I hope I have a time. There's no way I don't have a time on this map. Cool. I mean, this is not actually a terrible run. Plays pretty similarly. Over here. Ah, no, 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 no. Now it's a bad time. So what did I get? Like 78 seconds. So that's 1 minute 18. So I got about the same time. All right, surely I have a time already. Yeah, okay, 59. Cool, cool, cool. I want to play that other map. That one. Let's see if I can get a time on here. Oh, this map is kind of grindy, I think. Oh, it's not a teleport above. Damn. God, I need better eyes. Ah. Man, eyes. Having eyes is great, but like, could be better, you know? What is your hardest surf map? What, like that I've completed? I don't know. I don't have a lot of completions on surf. I remember this map being one that worked well with like analytic bot recording. Because or like slowing it down, time lapsed. Oops, bot recording. Nice. Yep. I remember getting stuck on this stage, actually. I would, like, get a good run, and then I would just, like, fail here. What? How did I lose a bunch of speed there? Like, I would get it if I was going the other direction, but... Why is the chat not auto-scrolling? Uh-oh. No way. Yeah, this looks a little bit too grindy. I want to get some work done today. Oh my. Almost got that. All right. See ya, Calibrate. Right. What was I saying? So like the teleports on that map are like glowing green. And I did a time-lapse effect on my YouTube channel. Actually, I might be able to find the video. Where? Yeah. Look at this. So, stepping one frame at a time, you can see it's like motion blurred and like crazy motion blurred. But it's not an effect. What it is I recorded the run at 1/100th speed. So it's 100 times slower. And then I sped it up by 100x. So I'm effectively recording at 6,000 frames per second, right? Because it's like 60 FPS, but at 1/100th speed. So it's like 6,000 frames per second. And then I created a video filter that takes 100 video frames and averages them together. So this picture is 100 frames, like smeared into one. And it creates this motion blur. This is effectively a time lapse of slow motion, and it's the same thing as motion blur. It converges to the same result as doing motion blur in like the game engine or something, or with like ray tracing. But interestingly, like when you hit this teleport, my bot playback would like lerp between the teleport source and destination. You wouldn't instantly teleport. You would move over the course of 0.01 seconds because the game was tick based, where like on this tick you're here, on this tick you're here, on this tick you're here. There was no such thing as a 0 time teleport in the old game physics, and this is like 2019, before I made the new game physics, which does have 0 time teleports. So it looks better on playback in slow motion, and it won't get this effect. Let's see if we can see it. So you should see like the green smeared. Yep. Not seeing the smear. Maybe we'll see it on a different teleport. Can we see it? Not really. Not seeing it there either. What was that? Oh, that was alt tabbing, right? I'm not seeing the big smear. Like it looks like it's just in one place. Oh my god, I'm like alt tabbing. Okay, maybe. It's hard to tell because it's like motion in one frame. Okay, there you go. So you can see that it's like behind my camera, isn't it? So like right here, that's, if we go back a frame, there's the door. And so it like went like this to really small. So like there it is here, but then it like zoomed out. The teleport moved you in one game tick away from that while looking at it, and went to like a small portion far away, and then of course we went behind the wall. So you can see it's 10 minutes of really slow down gameplay. Yeah, I'm really interested in that sort of thing where I would love to have. Anybody here doing that? I would love to have like a a service where you go to like givemevideo.behub.com or something, and then like you're like record this run in 4K, and it'll go like and it'll like send you the video. That'd be super cool, but Roblox is like super locked down. You can't just like run the game client in like a controlled manner, and the time control is also very bad. So I would need to like literally hack the game externally in order to integrate properly to be able to record the exact timestamps of like frames, because otherwise it's just kind of whatever's on the screen at the time. What I want is, okay, now generate the video frame for frame number 27. And then it does that, and then it says, okay, I'm done generating the frame, record it. And then, cool, all right, next frame, 28. Generate the frame, rendering, done. All right, record it. But it's just kind of like playing in the screen capture or something willy-nilly. I want like controlled time control recording environment of like professional, like Source Filmmaker, where like it's generating, it's like offline rendering, where it doesn't actually care what real time is. It just renders it as fast as it can go, and that's that. You like can't. I would need. I could do it with Roblox, but it would be a Herculean effort. I would have to like either hack the game client or have some sort of like alternate mode where I like network this, and I'm like I like send a request to my proxy server that sends a request to the Roblox server that sends a request to the game client, but the game client is running on the same computer that's recording it. So it'd be have to like generate the next frame, proxy, Roblox server, game client. Generate the next frame, proxy, server, game client. Instead of just like generate on the same machine. Like it's stupid. Roblox is really locked down. But when I have my own game engine, I can just write that code and it's done, right? So I can like a new engine, yeah. So I can, I'm rendering this at 2,000 FPS, but I don't have to do anything, right? I can like render just one frame. I can launch. I can have some sort of I can change the way the application works and just render a single frame and then close it, and it's like not a game at all, right? Or I can render out a video and then close it, right? It doesn't have to be this. And actually, I worked on this Vulkan video. This is like how I would want to do it. So this is someone was like mucking about trying to make this Vulkan video thing work from Rust. Because that would integrate well with the GPU and it'd be very fast to encode. And it would be cross-platform except Apple, but like who cares about Apple? And it would be hardware accelerated. So like I could bring in FFmpeg as a dependency, but that's like a C library, and that's like C. And so it'd be really hard to debug. And like I would have to read documentation. Blah. I'd rather write the whole thing myself. Haha. But turns out it's very hard. Who would have thought that writing video codec, driver interface, low-level systems programming would be hard, right? Who would have thought? I have like fixed some bugs. You've seen like pull requests here. I'm like Oh yeah, fix this bug specifically. Compute this, that. So I was like trying to work on it, but like it didn't do a whole lot. Uh, this one is probably my best work on this. I figured out that there's this Vulkan feature where, as it's encoding, it can either write the encoded frame back to the same buffer, or write it out to a different buffer or something like that. And the Vulkan video spec says that you may implement either of those, where it either writes back to the same spot or writes out to a different spot. And the author of this library, when they were running it on their GPU, it did not have the capability to write back to the same spot, whereas my GPU didn't have the capability to write to something else. So you have to implement both if you want to support all hardware. So this is a sort of like low-level stuff that you have to figure out when you're like working on this, but it's like really hard to do. So yeah, this is nowhere near in a like workable state. I would probably like do something outrageous like generate PNG images and then okay, come on. Run an ffmpeg command, something like that. Which wastes a lot of disk. Like that stuff is in memory just fine. I guess you could like, yeah, but no, then you're doing like ffmpeg API calls, and like that's, I don't know how to do that. I don't want to learn ffmpeg C API. Anyways, that's some fun stuff. Fun stuff for later. That's like, I would love to have that where like you can get a recording of your runs. I think that'd be awesome. Oh man. Wouldn't it be worth it to like try to make a Blender thing and do like port the Roblox maps to Blender, and then I already have a library that can read my file format. That's right here. This one. So this is the Roblox game file format that I use. So if you have this file, I think I have an example file. Okay, maybe not. This library can just like read it. And then you can be like, oh, the path was like this. This is the path that you took through the map, right? So I could totally like try to make a Blender thing. I feel like that's kind of a technical artist job to like make Blender look good and stuff. But that would be very cool. Be a lot of work. I would totally help out on a project like that. Yeah, it's probably a better option than to try to like harness Roblox to do the render, because it's just like you gotta hack it. It's too opaque, and then like Roblox has an anti-cheat and stuff, and like yeah. It's just not the right tool for the job. Roblox is a bad game engine. Oh yeah, so yesterday, after the stream, way after the stream, I updated the map website backend stuff. I was like, oh, I remember there's an update to the Roblox file reader library, and so I updated that to use it. Got this annoying thing. Ugh. I would like went through a bunch of code and like just did a bunch of nothing to make Clippy happy. Clippy is like Rust pedantry, where it's like, oh well, you could say this instead of that. You could like elid this lifetime. Oh, that's behind my camera. So it's like this. You could omit that. You could just like not write it at all and put an underscore, and the Rust compiler will figure it out. And it's like easier to read like that. So there's a bunch of little changes like that. This code is really fun to work on. The map check code. So that's in validation source check. It's a pretty wacky, crazy code. I tried to like write some comments as well. But like, it's like self-explanatory, you know, like I like being able to see the size of everything. This is gonna be 408 bytes in memory. Cool. So this code is checking to make sure your map follows certain guidelines. Very, very pedantically and with like outrageous precision. So this is like a type system, Rust type system representation of all the checks that it does on the maps. It's 576 bytes to know the full status of every single check. So it does all the checks and it writes all the statuses to this object. And then now you know the result of every check, whether it passed or failed. That's the result. Has two variants. It's either okay or there's an error. So if it's okay, then it exists. If there's an error, then it's absent. And then we can also see this like down here. So this guy is finding the result of the map check. So the map check is that giant thing. And then it matches here. And if it matches exactly this state where everything is okay and nothing is an error. So like it could say like error, absent, and that would also be valid, but we want it to be okay and exist. So everything is okay, everything exists, all the checks passed, then the result is okay. Otherwise, it's an error. So if you pass all the checks, then the result is okay. So this is like checking all the checks. And it's so interesting to like fully model the entire data structure. Love it. And then down here, this is the error message generator. So if you don't pass all the checks, then it'll do this. It'll take the checks and turn it into a string. And this is how the string is generated. So it's like the model is an invalid class. This is the class that we saw. Are you gonna eat cheese today? highly probable. And then like blah 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 blah. It's like just generating a big error message, or small, depending on how many checks you failed. So if this check failed, then write this to the error message. If it didn't fail, then this isn't written. Love this code. It's like so rusty. Just like I've modeled the problem with extreme precision. I love that about Rust. So like, even though I wrote this code 4 weeks ago, it's still fun to go through like this and like document it and then like refactor little bits and like do little fix-ups and stuff. Ooh, I could make it more precise and accurate. All right, that's enough distraction. So my idea for today, the reason why I was not actually going to stream today, I was going to do like mental health week or something, but I had a super good idea. And that's kind of why I'm like happy right now. It's because I had a super good idea for how to debug the problem that I'm seeing, or like the bug number 7. No way. What is the idea? It's very simple. Oh, is there any changes? No. I'm on the right branch. I want to write a unit test, and that's the idea. So down here, if I go like cargo test release. Oh, that's not gonna work, is it? Never mind. Engine physics, then test it. So if I test this, you see it goes and it'll like do a bunch of tests. Please, fast. Oh, tests. Okay. So this is the physics test, already inside hit nothing. Test collision degenerate north. So over in the code, I have all these tests. So anywhere that it says test like this, this is testing a collision. So it's like, all right, if you start here and there's an object here and you're going like this, what time do you hit it? I expect it to be 2 seconds. And then the test only passes if it's exactly 2 seconds. And I'm passing all the tests currently. So the idea is just to add a new test that tests this specific case. Hello, my favorite Roblox developer. How dare you call me a Roblox developer? I'm a Rust developer now, okay? I guess I would still be classified as a Roblox developer, considering I've developed Roblox games in the past. My bad. My fault. I only do Rust now. That's not true. I would totally be open to making another Roblox game with the Candlelit team. Make more money. Okay, so the idea is very simple. So it's gonna be like almost exactly this test. So test collision. Why is it degenerate? I don't know. Small MV, I guess. Do I have anything like that? No. Okay. So what is this? This is position, velocity, acceleration. So the position is 5, the velocity is -1. So it's at 5 and it's moving down at 1 unit per second and it's not accelerating and the start time is 0. And then there's like some platform that exists at 0, 0, 0. And it's gonna like hit it in 2 seconds? Oh, okay, because it's like a 5x2 platform or something. So it's like 5 tall, and the platform is 1 tall. So then, if the position difference is 5, then this is half a unit thick, and this is 2.5 units thick, and that's total 3. And 5 minus 3 is 2, so it takes 2 seconds to hit. Okay. So I'm just gonna make this a tiny little itty bitty number. It's gonna go to the side just like a wee little bit. So we're gonna go plus vec3 x, I guess. Why not? 31. You're like 30. It'll be fine. Let's just try it. Let's see if it fails. Fail. Oh. Oh, it failed. Let's go. That should totally not fail. My idea worked. Okay, so we fail this test. That should totally not fail. So now I can just run it over and over and over and over and over and like watch what happens at every single step and fix it. Fork? Okay, I couldn't smash the fork in. Where's the milk? I'm still drinking coffee. You can't have coffee and milk at the same time. That's outrageous. Okay, so this is super good news. I was worried that this would pass, and like I wouldn't be able to reproduce the bug. I think I'm gonna write it. I don't know. Like this is all right. Wait. Oh, I did the position. What? 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 Okay, what about this guy? Does that fail as well? I changed the test. It also fails. Okay. How did bug 9 go? Not good. I actually don't know how to reproduce it anymore. I didn't write down enough details to be able to reproduce the bug and actually debug it. I was like kind of depressed though. I had this really good idea this morning, and that's why I'm streaming today instead of taking like mental health week. You don't need mental health week if you're happy, right? I had an idea. Okay. So this is exactly what I want to see, and we can figure this out. So this is I also discovered that this fails, which is odd. Small offset. So like this should be exactly the same. It shouldn't affect the collision time. Actually, how big is the hitbox here? Oh my god. Oh, cheese is so yummy. It's like melting in my mouth. This is Balderson aged cheddar. 5 years. It's like really salty cheddar. For some reason, it's better a few days after you open the package. It like gets like quite a bit better. And that's now. Okay, what big size? Okay, 5 divided by 2. Okay. So it's a what? Is it a 2x2 unit? What incarnation is a unit here? Ah. Okay, so this is 2x2. You should read this as divide by 2. It's shift right by 1. It's faster than dividing by 2. Rotated. Okay, that's like. Oh, interesting. Really? Interesting. Okay, this is amazing. I don't really like the way that I've written this. This is divide by 2 30 times. That's a lot of times. Look at it. If I make this 32, it should pass. Because it's 0. Yeah. 33. I guess that makes sense. Pass. What? Oh. Oh. Is it doing that? Oh. Stupid order of operations. Okay, so it was wrong because it was wrong. Don't work with bit ops often. Yeah, because the loop. Actually. Okay, this might not fail anymore. No. Oh, okay. Interesting though. Look. So we just wrote both of these tests. I'm glad this failed, honestly. I was surprised that this one failed, but just because it would the order of operations was surprising. Okay. I think this will also fail. I don't actually know though. I don't know how big the like small movement has to be to make the bug happen. Okay. So this is literally the epsilon of the coordinate system of the representation. It is literally the smallest possible amount of movement. And then 33, we already tested that. It passes. Excellent. Okay, now I know why that was happening. This is expected. Everything is expected, and I can reproduce the issue. Yeah! Woo! Okay, so effectively this is 1 as a signed 64-bit integer. This x. It's 1 shift left 32. So when you shift right, it's still 1. When you shift right by 32, it's still 1. But when you do 33, it's 0. Okay, so we figured it out. So this is the smallest possible value. So this one does not fail, which I expected. Okay. Why, you know, it doesn't, it just doesn't make sense why it would fail. I don't think I need this test. Surely, right? Okay. Excellent. This is excellent. Okay, how do I make this suck less? So let's try P64 epsilon. Something to do with that. Wait, is that allowed? Surely not. Yeah, okay. Int. How do you... From value. The what? The value. Value. Oh, this is T copy. Okay. So this is splat. New? That is the vector. Yes. Okay, cool. Okay. So then we can do 0, 0. We could even do like this. The important part is that this is epsilon. You know what? I think the other way was easier to read. This is like crazy verbose. You know, like 1, you know. I could make it a constant, like x epsilon. I don't know if that would make perfect sense, though. Meh. Okay. Physics. Test within small MB. All right, here is the failing test. If you want to check it out. Hooray! Test failed. So now, what I can do is run only that test. Let me see if it fails. Ooh. Okay, coffee's gone. I'm gonna get the cow juice. Ooh. Jeez. Okay. Oh, this is such good news. These tests that failed are like how the physics can even work at all, basically. Like, I developed the idea for the like fixed point library because some of these tests, oh, did I just spit? I did. Were they were like lopsidedly failing anisotropically. Like just the southeast test was failing or something like that. It was like a couple of them, but like they're just the same thing from different directions. So it should be isotropic, where it's the same from no matter what your coordinate frame is. And it was a huge accomplishment to pass all these tests after I made the massive library for a month. It's still slow though. I need to fix that. Anyways. How I can do this. This is predict collision im. This is where it's gonna fail. Fev crawl. So cool. My code. Yeah, I have all these tests, so I can like rewrite the algorithm itself and then run the tests. If it fails the test, I didn't do it right. But if it passes the test, then I can have something faster with an equivalent feature set. Hell yeah. Oh my god. Okay, let's see what it does. I'll print the friggin'. Do I have like a transition branch? T. Oh my god, so many branches. Debug. Something called debug. Print more. Same. X11 mode is different settings. That's a Linux bug. Big platforms fail. Real? Oh yeah, big. Yeah, so this is exactly what I was talking about. Where like the fixed point library, wide precision stuff. Okay, we need stuff like this. This is looking good. Oh, face crawler. I was like writing the face crawler. Holy smoking donuts. Okay. So, debug. Pretty much inverse times dead. Ew. This is before the cool people library for cool people was real. Very, very cool. Okay. Let's see if I can snag some of these. Give me that one. No. All right. I wonder if I got those now. Yeah, that's a good idea to print that. Oh my god. Was that not? Oh yeah, that's not real. This is like a. Oh yeah, no, this is totally different. I reorganized the entire project. That's right. Okay. The function. All right, so we're gonna print that Goobert here. When you actually do it. Okay. I think I'm gonna start with a simple transition equals, and then like this. Yep. And then print it. Surely debug. Yeah. Okay. Gamma. Oh, it has it. Edge. MS Mesh Query Edge. Actual real? For real? Is it just like pretending or edge? Edge. Debug. No, it's there for the Minkowski guy as well. Can I like where query? Where? M. Is that a trait? Yeah. All right, what do you want? Vert. All right, can I say like, yeah, we debug plus debug. Yeah. Yeah, we debug. All right, we're gonna have a mile-long where clause. Let's go. Vert edge face. Debugging. I'm debugging. The bug. Oh, the cheese hit the sausage. It's over. It's contaminated. Okay. M. Yeah. All right. I know how I did this before. I didn't want to do it like this, but oh well. He's unlucky. All right, what do you want? M. Is this like any freaking M? M mesh query. M plus debug. Seriously? Seriously? Why does... Okay. Whatever, man. Just go for it. Oh. Well, that's convenient. You do like this. Oh, that's easier to read. Okay. Oh my god. Thinking. How? M. We can just do it like this. M. Boom. Done. Except not. Haha. Okay. What do you want? Qual doesn't found. Doesn't satisfy Minkowski mesh debug. Okay, Minkowski mesh debug. Real? This guy. Okay. And it hates me. Transformed mesh debug. God damn it. Debugging is so hard, man. Oh my god. It goes so deep. Earl. Really? This guy doesn't have debug? This is freaking way over here. Oh my god, bro. Holy moly. Okay, so I kind of want that like change outright. You hear? Ooh, oblique. Ooh. Look at this guy. You gotta put bug on your stuff. You are so right. No. Oh look, I had to do it here as well. I'm facing the consequences. The consequences of my actions. Okay. Can we test it again and it debug them? Miss. Do we want that? I think we do want that. Okay, so the real crawl does actually start pearly, and then it goes next, miss. And this is the denominator of the ratio, obviously. Okay. What the hell is going on? So we have a face vert. That's where we start. What does that mean? That means that we got them two meshes. We got that. So this is a collision test. We have our hitbox, and it's going like, that's it. That's the entire test. So, but the perturbance of the test that sets it apart from the other tests, and the reason why it fails is because it's slightly going to the side, just ever so slightly, by the literal smallest possible representation, an epsilon of the units I'm using. 1/4 billionth of a unit per second to the side, and it messes the whole thing up, which it shouldn't. So why does it fail? Okay, so how does the algorithm work? Well, so it goes like this, right? It's slightly going to the side. I'm just going to exaggerate that it goes to the side. So what it's doing is it's tracing backwards to infinity, where the starting point would be, and then finding the face edge or vertex to begin the face crawl. So that would be like this, probably, because it's like going like this. So how does it find the fart vertex? Fart. Okay. Apparently, it is correct, I guess. So I guess the setup, we can sort of skip the setup and pretend it was perfectly set up, which I assume is true. So it's sitting like this. It's 5 units above the center, and it's going like that. And so it knows that the current closest point between the two objects is face vert. Oh, which one is the left? Oh. Who did this? Who wrote this code? So it's like physics left relative body platform mesh hitbox mesh. Okay, my guy is on the left. So this one is on the left, and then the hitbox is on the right. So it's left, right, face vert. So it's a Minkowski face variant face vert. So that means that it's probably this face facing up, and then one of these verts. So it's picked like something like that. I'm going to guess this is like a precision error where I'm like, truncating precision during the calculation, and it's like messing with things. But there's certain calculations that it's like really hard to keep the precision. Probably what should happen here, it should go phase vert, hit, and it should never transition to any others. That's probably what should happen here. Let's run the test above and see if that's right. So degenerate straight down. So we can run the same test, or the nearly the same test. We can see it's like nearly the same test. So this is the small mv test. We're adding this small constant to the velocity, whereas this one just goes whoop, straight down without that epsilon value. So let's run this one and get the same debug output. So no capture. I predict that it's going to print miss, real crawl, face vert, hit. Oh, so miss, real crawl, hit. There's like 0 steps. Fantastic. Brilliant. That's a perfectly working algorithm right there. No way. So that's what it should look like. It should basically be exactly like this. And there's 2 going on, because if we look at the code, test collision, it also tests a rotated hitbox. So it tests it like this, and then it tests it like this, just because like that's easy. There it is. Test collision, boom, boom. Clone the body, clone. Clone. Yo. So it looks like the setup is working, which is good. It's also insane stuff. Take me up to the top of the I guess it'll be like this. We can like kind of from here. Hole. Alright, I'm just gonna steal this, and we'll like. Does it even know? Yeah, no, it has no idea. Okay, so face crawler. So what's going on? So we have a face vert, and that is a face type fev. So we're entering this code path, and it is literally just going straight to this. Okay, so we only really have to look at this GUI. Yeah, so we can do like print that ND. Nor. Oh. So then this guy would so this is like what the hell going on? Okay, so this is like left. Yeah, okay. So what does this mean? So there's okay. There's a lower time bound, a upper time bound, and a condition where you have to be going into the surface in order for it to count. And if any of those are false, it doesn't count the like solution to two objects intersecting as being a valid solution. Wow. So then it goes like, oh, okay. So we can go. Let yeah, and then let up, yeah, and then let into. What's that? You. Boop, 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 boop. Mm. 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 Can we? Does that? Can you do that? No. Mm. Mm. Who did this do? Can you do that? Okay. Okay. Um. Cool. 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 Do we need to know this? I think we already know, so that's fine. All right, go ahead and run the track. Okay, let's see what correct looks like. Okay, so face normal is straight up. Makes sense because like that's the normal vector, you know. And then the d value, this is like the distance times the normal, something like that. DT 2.000 seconds, so that's why it passes the test. So it succeeds all of these restrictions, and then yay. Okay, let's see the failure. Yeah, failure. Oh. Why do it be doing like that? Why does it print next first? Wait a minute. And we don't know where it starts. Crawl self. Oh. Edgevert. Edgevert. Maybe that's okay. Okay, let's go. Oh. Run. No, 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 no. Wouldn't it be great if I had a visualizer and it was like, oh, that's wrong, and then like I solved it? But no. I have to do it all in my head. Well, I'm not seeing it right now. You know what I'm saying? Okay. Oh, interesting. So we can see the algorithm in action here. You can imagine it. It's called the face crawler. What it does is it tracks the closest point on the surface of the object to a point on a curve. So in this case, it's a parabola, but it would also work with a straight line. Actually, no, in this case, it is a straight line. It's a parabola that is a degenerate parabola because it's a straight line. And so that's great. Isn't that great? Okay, so yeah, you can imagine like it's in order to start the algorithm, you have to start somewhere on the curve, and you find the starting closest point, and then as you move along the curve, the closest point like moves up, and then it goes across an edge or whatever it does. And that's the face crawler algorithm. And when the curve intersects the closest point, you have hit the mesh, the convex mesh, the object. That's it. That's how the algorithm works. So much implementation. So what's going on here? When it says DT 2.0 low up into. So it's doing the calculation. It's going like, but there's a time limit because it's doing the initialization of the algorithm. It's finding the closest point to the starting point. And how it does that is it traces it backwards in time to infinity. And then that's easier to start from. And then it's like, oh, starting from infinity, the closest point is like right here. And then it traces along the surface until you reach the starting time. And it's like, oh, now the closest point is here. In this case, it's extremely simple. So as it's crawling in from infinity, it sees, oh, it's going to hit at time t equals 2. But that is after the upper time bounds for the starting time limit, because it starts at 0 seconds, and then it hits at 2 seconds. So as the algorithm is initializing the closest point, it's crawling in from infinity, and it stops at 0 seconds. So it's starting at negative infinite time or whatever, and then it starts at 0 seconds. So it sees that this collision is at 2 seconds. It's like, oh, the upper bound has failed. This is going into the mesh. So like, it's going. It's not like coming out or something. It's not like coming out the bottom. That would be not a collision. That's like an uncollision, right? And the lower bound is satisfied because like 0 is above negative infinity. That's great. Yeah, so that's why it says up equals false, because the upper time limit is exceeded. And then it does effectively the same calculation again after the algorithm is initialized, starting at the starting point, and it goes again. It gets the same result as this one, except this time it's within the upper time limit. So it counts as a collision rather than a miss, because all of the conditions are satisfied. So then in the code, that is, oh my, right here. No, it's up here. So we have the three conditions, the lower bound. So is body time less than or equal to dt? Yes. Is dt less than or equal to the current time limit? If we've already found a collision is this collision we're detecting now sooner than the current best one. So that's why it says best time. But it starts out as like the time limit of the, because like the physics is running in like little bits, right? So there's a time limit for the collision. It doesn't want to see into the infinite future. That'd be slow, kind of. And then here's the condition, right? This and this and this, and here's what's printing it. And then over here, it's printing true, true, true. And then if true, 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 then we did a hit. Wow. And there it is. There's the hit. Wow. 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 So this is what a successful algorithm go through looks like. So what I'm seeing is that the setup is actually failing, which is not what I thought. So it should be exactly, I don't know, actually it could, no, never mind. So it's going to the side just like slightly. It's literally the smallest possible value, but the range of values is large enough that it will eventually hit the like clipping plane of the side, and like the closest point between the objects will be like on the edge rather than on the face. Because it's if the degenerate case in the unit tests, that guy, it is going exactly straight down, so it never crosses the like invisible planes that extend off of the object that like would mean that the closest point is on an edge or something between the two objects. The closest point is like on an edge versus the closest point is like on a face. So it never leaves that bounds as it's like coming down from infinity. Whereas this one, it has the teeny little velocity to the side. So eventually it crosses that boundary, and then when it comes from infinity, it's starting from a closest point on here, and then it has to crawl along the surface to the starting point, which is definitely inside that like invisible bounds. So this is a different algorithmic setup. So it is actually the setup failing. And I was wrong when I said that the setup isn't failing. Okay, so that when the real crawl begins, it realistically should look exactly the same. It should be this exact same thing. And this is almost exact same thing. No, actually, I think it is the exact same. It should be recreated verbatim. This should run exactly the same. So it's the that's failing. It's the setup. Oh my gosh. So let's go over to the this thing. Begin setup. Oh my. Okay, so that's cool. Isn't that cool? Okay, so this internally does a crawl. That's just great. Okay, so we run this guy. It says something different. So the old one said face vert. The real crawls ended on or started on face vert. And that is correct. The other one should also start on that. So it's correct that the setup misses in the later one. So the setup misses. That is technically correct, but the setup, it doesn't set it up correctly. So this is irrelevant because the setup is incorrect. So we want to fix the setup. Okay. Wow. 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 Okay. So potentially this is correct because it's like it's off at infinity and it's coming in at an angle, a very shallow angle, but like eventually it will be on an edge vert. I think this is correct. Ah. You know what? I could actually do another test. We'll see if it fails as well. Okay, brilliant. We got him. Okay. Uh, I think I'm gonna actually commit this. So, um, bug, 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 bug. This I don't like. Bug, bug, bug. Great. So now this is an easier comment. This is cool. Where? Physics. Simplify trait bound with an D. Slightly simplify. Okay, and then this is my like current debug stuff for debugging. I'm gonna put this away. Maybe. No, I'm not gonna do that. Get owned. Okay. So I need more printing. Yeah. Ugh. Or, yeah. Yeah. Don't want that. Okay. So, in the console, it says it starts here. So that's starting from infinity. That's the face crawler algorithm setup, which uses the face crawler to set up the face crawler. It's very modular and reusable and epic. It's like effectively running the algorithm twice, but like with in like reverse and cool stuff like that. It's like time symmetry. It's really cool. It's really cool. Like predict collision in is predict when it will collide and they are like going into each other, and then predict collision out is predict when they stop intersecting, right? And it's all it does here is it does a time reversal, and it's so like negative time limit, negative start time, negative the resulting time, and it's just doing the same thing but negative. It's really cool because the algorithm only works on the outside. If the meshes are actually intersecting, it breaks down and it doesn't work. But you only need it on one side because you can use that time symmetry. Yeah. Anyways, I'm actually going to have to debug this This is the fart algorithm. Very cool. This is like the beginning point of the setup. Fart. Bert. I could just call it Fart Bert. Nah, this is a better name. How are you? Right. Okay. So it says it starts at edge vert, which is an edge of a Minkowski-Bogowski. So what does that mean? That means that an edge on mesh 0, so this is mesh 0 edge, and a vert on mesh 1, so this is a vert on mesh 1, are like forming a edge on the Minkowski sum of the meshes. So that's like one free variable forming a line like this. I haven't really explained Minkowski, but I'm not going to right now. I want to figure this out. So I need to look at the edge case. Haha, it's the edge case. Face crawler. So the face case is here, and then the edge case is here. Edge case. So when you're crawling along the surface of a mesh, it doesn't matter if it's a Minkowski sum of two meshes or just like a plain old mesh. It'll work the same, which is like this algorithm is supposed to be generic across both, but it's not because const generics is not stabilized in Rust. So you're tracing the closest point to a curve along the surface of the mesh. So let's say you're on a face and then you trace it onto an edge. What can happen if you're on an edge? So this is like, okay, we're currently on an edge. Where do we go next? That's what this is doing right now. So what can happen is you're going over the mesh like this, and it can like go back down onto a face, or maybe the curve is like this, and you like go across this, and then you go onto a vertex, and the vertex is the current closest point to the curve, and then like you go onto an edge and then onto a face. So from an edge, you can either go onto a face. Is this under the camera? Not quite. You can go onto a face, so you can go down to a face, or you can go up to a vert. So you're on an edge, you can either go to a face or a vert. You can't go edge to edge. You can't go face to face. You can't go vert to vert. And you can't go vert to face. It's only face, edge, vertex, edge, face, edge, face. So it's like you have to go through edge to get from face to vertex as you transition across. I have this written down somewhere, but yeah. So there, in the edge case, there's two ways you could go in terms of transitions. Well, there's three. So either the next transition is a face, the next transition is a vertex, or there is no transition. We went off to infinity, or we reached the time limit. There is no next transition. So that's miss. No transition. Great. So let's start putting in some debugums. So I printed the edge already. We don't need to print the normal. It's already print it? I think it printed. Oh, we do need to print a normal. Oh goodness. Okay. Huh? Wow. So let's just print the edge normal here. Edge normal. We don't have a D value right now. Okay. Okay. That wow. Okay, and then we want to do the day. So what is this doing? So we're currently on an edge on our face crawling. We're sitting on an edge and we're seeing what happens next. Where does the as we trace the closest point, where's the next transition? Oh, so we have our mesh and we query it for edge faces from the mesh query thingy. A function is defined to find out which faces are beside this edge. And this actually just returns them here, and I iterate over them. Well, it's a thing. So presumably, goodness gracious, this is a edge. This is an the ID of the face that's beside the edge. So we grab the normal of that face that's beside the edge, and then cross product, and that helps us like determine, are we about to exit off the edge onto that face? And this is solving the quadratic equation of when the curve hits the like surface that divides that transition onto the face. So when the curve hits that plane, you should transition onto the face. And this is the solution, the time of intersection. So now we're iterating over times of intersections of curves hitting planes. One curve hitting one plane. Well, per edge or face. It's very confusing. I spent a long time writing this. Okay, so I want to... Why is this shorter? Because it's only one face. Okay, but there's two edges. Or two faces. There's always two faces. This guy always returns a list of two faces. I don't know why it says const. This should be two. There is always two edge faces. Two. Wow. Swing. Wow. So here you got edge face. Okay, that's ND D DDD edge. Okay, this is making good sense. I'm going to steal this. I guess we don't care about that. Okay. Oh, is this the D value? Is this the D value? invert some delta pos. Ew. Okay, yeah, that is the D value. Surely. I think that's A0. Yeah, okay. D value is here. D over 2. Mm-hmm. Printy. Oh, you know what we can do? Is we can do this. Okay. So we don't care about this. What we do care about is there is an edge face. There is always 2 edge faces. And we care that the boundary normal that's like defines the point at which it transitions from an edge down onto a face this is the definition of that plane. And then we can see the 3 conditions. The conditions 3. C3. Oh my goodness gravy. It is so freaking complicated. I want this guy as well. Why did it do like that? I can't explain. What? That was like a Qbox bug. Holy smokes. So it's the lower bound. There's the upper bound. And there is the into bound. Okay. So now it will print something. I have no idea what that is. Okay, let's print what a real man does. Oh, we can't actually compare because it's not real. Okay. It doesn't do that. It doesn't go through that path. Okay, so then this one, so begin setup debe oh it's so problematic. I don't know what is this? Which face is this? What face is that? Or it's a vert? Who knows? I need a visualizer. I was like, oh, is that the same one? No, it's not. There's 2 faces. Okay. Face, edge face, edge face. Okay, so this one, you hit it at negative 500 trillion time. Negative? Is that because of the time inversion? Look, it can see the future. It can see that it's about to hit that bad boy, but it thinks. Do what? But it thinks that the upper bound is not satisfied. It will. Should it be satisfied? Shouldn't this be like 0? Wait. Low up, true. Is this an overflow bug? Do I need a sum none variant for the time limit? I might actually need none. I keep overflowing. Like, look. In the physics guy, when it's doing the thing, it sets that the starting time is the minimum possible time divided by 4. Actually, I could make this faster by doing like 2. So this is like the literal minimum integer 64 that is possible, representing negative infinity. But if I actually use negative infinity, it overflows or underflows, I guess. So if I just do like that, you know, oh, time. I don't have a time shift. Gah. Man, you don't cut that out. I think I'm gonna macro it. Div mall, you know. Okay, impl time. Simple operator. I don't know. It's I don't know. Whatever. RHS direct operator. I don't know. It doesn't matter. Okay, so who did this? It's like RHS is type, and then the should be oh, okay. Yeah, no, we need. Okay. I guess we don't need the type. It's gonna be time I64 operator. I don't know. Okay, so method and op. Is it also an ident? Is that a ident? Indent, nice. I forget. How do you say that? Method. Tie. Okay, tie. We'll say tie. Okay, so then this guy's here. Hello. And then, oh, that didn't work out. Oh, it said double. Okay. Okay, boom. So then this is boom, div. Op. Boom core. And then div. Oh, yeah, that makes more sense. Why is there spaces? Get out of here. Opt for time. So this is the guy. This is the guy. So it's gonna be method dot method boom like that, semicolon, and then same for mul, and then it replaces this. Oh my god. Mul. It doesn't work. 4. Mul. I see. Operator. Okay, there's no. Tie. What is this? Ident. How do you do this? Is it like EXPR? Struct? I don't think it's EXPR. I don't know. I forget. I forget how you do this. God damn it. Tie EXPR. So I'm never trait ident. I guess I could like ident struct ident. Okay. I'm working on a game engine. Should I use SDL2 or GLFW? Isn't SDL3 real? SDL, I believe, is a much more complete, do everything for you library. Like all batteries included, sound, window creation, blah blah blah. GLFW, I think that's just window creation, right? So it depends on how much you want to make from scratch, how much fun you want to have. The fun level of the project. Choose the fun level of the project. Also the like how much time it takes level of the project. All right, what? Okay, yeah. Okay, I'm doing it like this. Okay. I'll just do it like that. Okay. Boom. So this is ident. So then we remove it from here and we go boom like that. Div. Yeah. Okay, and then the one that I additionally wanted to add is shift right. Sure. Cool. I love macros. Okay, and then shul. Okay. Yay, we got a macro. Woohoo! I'm making my game engine C++. The programming language will be Lua. I hope you like null pointer dereferences. Seems like you also like mature libraries, so. What do you mean? Well, I mean, I'm using Rust, which like, there's not a lot of mature libraries for like writing game engines. But like, I'm basically doing everything from scratch anyways, because I like to. So it's sort of fine for me. Build a debug. It might warn about underflow. That's a good idea. Twitch chat. So C++ and Lua, like anything that's not Rust, you're basically gonna have these like null pointer index or attempt to index a nil value at runtime, right? You're not a real programmer if you don't code your own game engine. Wow. I guess I'm a real programmer, according to Notch. I think that's silly. It's more of a toy or like an exercise. Like I'm making my own game engine because I think it's fun, not because I think it's going to make me money or because it's like the best way to do it. Although I think I can do things better than other game engines for the particular implementations that the game I'm creating requires, namely like really accurate physics. And immensely powerful time control over simulation time and whatnot. Oh, cheese. All right, I'm gonna put this cheese away. So yeah, it totally depends on like the game. Like, okay. I've heard about a game where like the shtick is that the game opens multiple windows and you like interact between them and they're like sort of fluid, and that just like, why would a game engine do that? That's the whole point of that particular game. So you have to make your own engine for that. But if you're making a shooter and you pick up loot and there's maps and you kill people, then like game engines already do that. Why would you make your own game engine? That's just a waste of time. So it totally depends on the game and like what your goals are. There's no like, oh, you always have to make a game engine. That's just not true. And like in most cases, you probably shouldn't. You should only really do it if you want to waste a lot of time. Or you have a very small game that has a very particular gimmick that game engines can't provide. But that's kind of like if you're trying to make money, right? I'm not really trying to make money here. I just want to do programming and have fun. So my goals are beyond the comprehension of AAA game studios. Is it good for a beginner to learn coding by first making a game engine? No. Use Godot. None of them were fun to make a solo project. That's not good. Documentation of all the features, going through reading a whole essay. Yeah, I struggle with that where I can put the cheese away. So what I was saying is when I go to make something, I have an idea. I already have an idea of how I think it should work. And so I already like know how to make it. And then I just go do it instead of like looking up a library that already exists that does what I want. So I never really interact with documentation. So I can see where you're coming from of like having to go through documentation. I'm very particular about, I don't want to use a library if I think the implementation is bad and I can make a better one. But like, the thing is, I rarely know how the libraries work in the first place, or that they even exist, right? So I'm always going off on tangents and making little things. Okay, well this is good here. Good. Okay, so now we can shift time. Oh my god. I really like the shorthand of bit shifting these integers thingies. It's one line of code added. Macros are sick. Go macros. Rust. Yeah. Okay. So does it build? Okay, so I just divided by 8 rather than dividing by 4 using shift by 3. Okay. What else? What else can I do? Let's try 4. Gotta deliver a school project. I do want to say one thing. I think that the best way for a beginner to learn programming is to find an example project that's close to what you want to make, and then it's already working and you can tweak it to make it closer to what you want, but you're starting from a working example rather than a blank page. And if you break it, you can just go back. I think that's the best way to learn. Okay. That's how I learned Rust. Game anything. Okay, build with debug. Let's try that. Try that. Go. Blah. Doesn't look like it died. It's still there. Okay, so it doesn't seem like it's overflowing. Good idea. VV nice. Const. We need const traits. Scam. So really, I should be able to specify no time limit. Oh, the start time. Oh. Is that even ba? I don't know. What happens in this guy? So body time. Ugh. Yeah, this is not the greatest code here. So, what this I could. Actually, that could very well be faster. To have like an if statement every single one of them, where like if the time limit does not exist, then the bounds check automatically succeeds, as if there is no bounds at all. Interesting. Body time. Lee ratio, yeah. So I don't think I ever subtract or something like that. Okay, so that is doable. I don't think it is the bug, though. I don't understand why this is a large negative number. Oh, now, wait, I do. How big is this negative number? 1, 2, 3, 4, 5, 6, 7, 8, 9. 15 billion. Oh. I think I know what's going on. So it's supposed to pass this lower bound. So this actually would fix the bug. It's supposed to pass this lower bound, but it fails because it is smaller than the smallest or more negative than the largest possible time. So the most highly negative possible time is like it's a number. I'll just calculate it. No math. Interesting. So my idea to use optional values is actually the solution to this. Cool. So we have 2 to the power of 63 minus 1. No, it's negative actually, so it's like this. And then divide by 1 billion nanoseconds. This is the maximum possible time. Oh, God. We'll just go floor. So the maximum, the most highly negative time is 9 billion seconds. And then this is saying that this time of collision occurs at negative 15 billion seconds, which is before the start time of the algorithm, which is past right here. So this value is like 4 billion or something, or I guess it's like 2 billion because it's divide by 4. 9 billion divided by 4. So there's not this is effectively supposed to be negative infinity. It's never supposed to fail the test, but it's failing the test because we have a much a number with more bits than this number that's being compared against this. Okay. Well, I can do this refactor. I can do this. It might make things... I mean, honestly, it might make things faster. These calculations are so slow that doing an if statement and then doing no work is probably faster. XD. Okay. Good debug. I'm going to make a branch. Oh, why don't I call it debug bugged 7? And then we'll just go like, ooh, yeah, ooh. We can actually do like this. Jeez. Okay, please. So that's fine. Bit shift. Okay. So this was a hack. This code here, this was a hack. I was like, surely the calculated time won't be larger than negative infinity, right? But it's not negative infinity. It should have a representation that means that. So face crawler in the old algorithm, next transition. So body time is actually like lower bounds, and then best time is upper bounds. So time, they're both time limits. I was representing them using a range. Maybe I should do that again, because you can have you can represent an unbounded range. Haha. Okay. Where was I doing that? Physics model. Down here. Yeah, range. But that is a definite range. I want a trait object thingamabobber. Do I? Struct range from. The what? Okay. A range only bounded inclusively below. Yeah, we want this type of stuff. Oh, okay. Where's the freaking trait? Oh my god. Range bounds. Is that real? Is implemented. Yeah, okay, so I think we want this. Start bound. Ooh. Ooh. Okay. Okay. Now we're getting somewhere. End bound contains. Okay. Into bounds. Oh. Oh, interesting. Cool. Okay, so I want this guy. Oh, yeah. Unbounded. Ooh. Clone. Wait, clone. Oh, cloned. Okay. So, face crawler algorithm. Start time limit? Nah. We want like that. T. Time. I believe that's correct. So range no. Oh. Who did this? No. Right here. Instead of ops range, we want ops range bounds. Is that real? Yes, it is. So this is a freaking trait. The trait. So then this guy hates me, but instead of start time, end time, we do range bounds Oh, this is a uh, uh, range imp. Is it clone? Copy clone? It's a standard library thing. It should be fine. It should be fine. So this is range dot start bound, and then this is just the range directly. Range, surely. It's okay. That's okay. Mismatch types. Is it gonna complain me about copy as well? Surely. It should be fine. It should be fine. It should be fine. So then this is actually none bounds. So this is unbounded, like that. It is literally bounds. Closest fab not inside. Buh. Bound. Who did this? What is this? What is this? What is this? Bound. Reference. Do like this? Is that okay? Not really. I don't think that's allowed. Can you from bounds? Real? Real. Okay. How do you... is that... Okay. Okay, just relax. T enum. So brilliant. I think I need copied or something like that. Is there goobers for this? Clone copy as ref. So I want the opposite of that. Map. Oh my god, bro. Into bounds. So I want like the other way around. So cool. I thought it was bad, but I just didn't get it. It's good. Hmm. Damn. I believe. Okay, I believe. I think probably this should receive just a full range. Never mind. How do I construct a range from a bound? I don't know if you can. I mean, this isn't ever used directly, so maybe I just say, oh, it's bound. And we're chilling. And we can also pass reference. I guess time, it's not that big a deal. It's also map. God, does that like fix everything? Holy smokes. I think this is just gonna fix like a lot of stuff. But first I have to like break it, of course. Okay, so this says it wants a reference. Can I like map dref? It'd be nice if I could do like copied, but what about dref? As dref. It's fine. We can just go like this, and then crawl. We can say bound, unbounded, and then crawl. We can go like this. Bound time limit. Bound time, and then is it going better today? Insanely better. I'm pretty sure I am on the way to fix a bug. Bug 7. I had a brilliant idea that like jolted me out of depression. So like I wasn't going to stream this morning. And I came up with the idea of writing a simple unit test that demonstrates the bug, that like makes the bug happen. And it worked. So this is like exactly the same unit test. So this one is testing a degenerate case where it falls exactly straight down. And then this one is, what if it's like going to the side at just the tiniest bit? So it adds this like tiny sideways velocity that's so small. This is 1/4 billionth of a unit per second to the side. So it just is almost falling straight down, but not. And it hits the failure case. We got him. And I've been like staring at the output of the debug log, and I figured out a logic bug in the physics, and my code is becoming more rusty and beautiful. No way. Do. Tricky. But precise. Tricky but precise. All right, watch this. So, maybe I'll just define the function here. Actually, did I ever call it inside of here? No. Okay. So I'm just gonna like write a little function here. Oh no. Yes, I can. I can. Function ratio. It's kind of like into gigatime. Shh. And we take 2 arguments. Oh goodness gravy. Oof. And it returns bound gigatime, I think. And then this is the function. Bound says it's bound.map. Uh-oh. Oh. Wait. No. No. We want time. Time is not a bound. Time. And we'll deref it like this. Yeah. And then this one goes like this. Start time.map. 2 gigatime. No function arguments. Is there no bound map? Please tell me. Oh, we need the thingy. Okay, bound. Boing. Ah, I wrote a bug. No. Bug. Got. Okay. Got. Who did this? What is that? Expected. Ah, I see. Okay. Map. Is that real? Map bound. Who did this? Expected 1 argument takes 2 arguments. Ooh, okay. I see. Okay. Rubber. Yeah. Unfortunately, it's a closure. I want to do like a simple thing, but is it bad to write a closure as a variable? I don't know. This is fine. I'll just do it again. All right. But look at how amazing this is. Time limit dot map. It's the same function call for both of these. I thought like, oh, those are duplicated code and like it's the same thing, but I didn't really know how to do it. And then now I'm in the middle of this other refactor, and like the precision of the Rust standard library expressing this concept of range bounds is fixing bugs and deduplicating code. Bug 7, did you squash bug 9 yesterday? No, I did not. I did like a tiny bit of work, but I couldn't really get into it. But I'm totally into it now. So next transition, we need this same Goobert like that. I wonder if there's helper functions. Probably. So it's not actually body time. It's lower bound. And it's not actually best time. It's upper bound. I'm gonna need little helper functions, but that's okay. Okay. So these types are actually bound. Oh, that didn't work out. Bound. Gigatime is a stupid type alias. It's an overly accurate time ratio. So it's a ratio of 256-bit numbers. So it's overall there's 512 bits of precision. But you need that precision in order to extrapolate a parabola down to the finest precision of world space coordinates with no aliasing. So like, if you imagine that time is an integer, which I do represent time as an integer here, it's a 64-bit integer, and 1 billion is 1 second. So it's like nanoseconds, effectively, as an integer. So if you imagine like a parabola through the world, and like you move 1 nanosecond at a time, what if it's going really fast? Then like 1 nanosecond covers more than one quantum of like the world position units, epsilon, like the smallest possible Planck length of the world's coordinate system. So you need this like gigatime thing to represent time as a ratio, which is like the output of some other calculation, that when you plug it in to the parabola, it's always precise down to the nanometer, or like whatever the epsilon is for the world coordinates. Probably there's like a more elegant way to do it that like doesn't waste as much computation and stuff, but yeah, that's how I'm doing it right now. Okay, so this is amazing. So we say crawl, and we can, for the start time, it's actually a lower bound. It's not a start time. We're not like starting at that time. We're just saying throw out any results that do not satisfy this bound. But there's an option here that is unbounded. So it's like lower bound. I think I want to change the name. And the upper, wait. Okay. The upper bound is mutable. Do I want to? Oof. Next time. Next. DT. Okay. This is so precise. So I have entered the precision zone. This is supremely excellent, because this was all sort of up in the air before. So like if we're crawling along a parabola, and there's a number that's like on the bounds. Does it count if it's like below or above? Like, Is that included or excluded? Who knows? But this data structure explicitly specifies that this is exclusive. So if it's on the bounds, it doesn't count. Or it's included. If it's on the bounds, it does count as being in the bounds. Or it's unbounded. There is no bounds. It's always within the bounds. Precision engineering. I just was like doing negative infinity and then like plus one kind of Whereas this is accurate. Oh my goodness gravy. Okay, so we want this to go together like this. And then the body time equals. So now I have to say that this is like bound included or something like that. Like I have to decide. If you transition on to the next thing, and then there's another transition, if it's a 0 time transition, is that allowed? I think that it is allowed because you can go like straight through the corner. I don't know. This is where it gets complicated, and this helps me express that complication. Oh, it's so good. I think it's included. I think you're allowed to have 0 time transitions. If it was excluded, then you would be forced to advance by the minimum quantum of gigatime, which to be fair is extremely small, but like 0 is very entirely possible as well. I think this is correct. So when this returns a next transition, the minimum time is like moved up. Previously, maybe there was no bound, but now there is. It changed. It became bounded, even though it was unbounded before. So this is not start time. This is lower bound, and this is upper bound, and this is I'm gonna name these as well. Oh my god. I think I'm gonna do this as well. We're just gonna ampersand right here. Yee! To make it look nicer. And it's so good. It's so good. The function signature. Okay. Next transition. So now I have to actually make it work. We're gonna rename these as well. Lower bound and upper bound. Yes, sir. And yes. So the upper does it matter? Break. It's always in order. God, I have so many little optimizations. So it can break out of the loop because these are all always in like descending order. Is that true? I tried to make it true. Okay, the thing is, it's a freaking ratio. It should be true. Oh my goodness. Okay, so how do you what contain? It's like we want like bound contains, but okay, who did this? As ref map, amazing function. contains. Oh. Oh, okay, so there is no bound contained. There's range bound contains. Wait. God, Rust is just unbelievably, amazingly expressive. The type system, 7 million chef's kisses. My code is becoming more accurate because I recognized that one of my types is a concept that exists in the standard library, and the precision of the standard library is making my code more accurate. Oh my goodness gravy. Okay, so what the hell happening? Who did this right now? Actually, this isn't. Oh yeah. Good. Okay, I got it right. So I have to do like map. Look, so less equal, less than. This is excluded. This is included. So I was implicitly doing something with the bounds. I'm pretty sure that's the standard range. Oh my god. But I can actually express everything now. Okay, what you gotta do? Bop. Hello. Bow. Bow. Okay. Lower bound dot. Oh, cloned. Oh. Interesting. So there is actually a cloned, but no copied. I wonder why. Okay, so there's no like cool people function for this. I'm gonna have to write my own function, but it's totally okay. Okay, we'll do like check lower bound. I'm just gonna write that for now, and we'll call it this guy. Bull. We can say like this. And then match. And give me those. Give me those. Give it to me. Oh. Okay. Unbounded. True. Literally so true. This is doing copy. Can you deref? What do I call this? Okay, so if it's included, then lower bound, the time must be less than or equal to dt. If it's excluded, then it must be less than. And then checking an upper bound. The argument order is also the other way around. So this is now the right-hand side. So this is dt is less than or equal to, it's included, the time, or if it's excluded, then dt must be less than time. And if it's unbounded, it's always true. It always passes the bounds check. If there is no bounding, it's unbounded. Wow. What is ratio copy? It is. I want to say this. And it only needs to deref if the bound exists. Let me just deref. Oh. Ugh. Yeah, I'm gonna like make this really short. No worry. From what I saw, this is actually better. Okay. So this guy appears several times, and it is precisely lower bound dt. Like that. And it hates me. Ooh. You good? Oh. Unfortunate. That is unfortunate. Unfortunate. That is so unfortunate. I need like 8 million. Trade bounds here. That's so unlucky. So we have LHS here. We know that it's this guy. $128. Jesus. We don't need that. We need parity trade. This sucks. I did not foresee this. I didn't realize the ratios were different sizes, but it'll work. Need the parity trait. Super unlucky. Okay, so DT is ratio numden. Copy. Okay. Jesus. Nope. Do I need to say that on those stupid things as well? Oh, jeez. Probably. Okay. Very interesting, but unlucky. All right, so now this guy. So this is exactly upper bounds check, DT upper bound. With a ampersand, you goob. Okay, let's go write the same thing again. Yo. So now we need the old LHS. Let's go. It should just be like this. Oh. Do I really do den first? There's no way I do in the ratio library. Yeah, see, numden. You good? Cool. I just kind of winged it. Cool. Okay, and then we happy? Yes. Okay. So now the bound is a new type. Oh, equals dt. Wait, what? Oh, okay. Good. Okay, I see. Okay. That's, I mean, I didn't have to do this, but it is a little bit faster. Yeah. Okay. Gosh. So, what is this? Is this an inclusive bound? Um, it shouldn't matter. There should be no such thing as two bounds, two transitions, which resolve to the same timestamp. Oh. I guess you could go into a corner, but then it would immediately go onto the vertex in 0 time. So this is a inclusive bound. No. Yes. Yes, this is an inclusive bound because 0 time transitions are allowed. Bound. Inclusive. Yar. Yar. And then I think all of them are inclusive. I don't think there's any exclusive bounds. I can actually just... Because zero time transitions are always allowed. It should be good God. Like deterministic, regardless. Okay, so imagine like you're doing the face crawler algorithm. Ooh, there's a path. Ooh, you're tracking the closest point, and it's going like this, and it goes exactly into the corner. Exactly into the corner. So there's two transitions that it's checking. So it's in the face here. This fails. There's two transitions that it's checking. Two face edges. There's this face edge and this face edge. Well, there's also those ones, but those ones will evaluate to false. So these ones, the upper bound, let's say it does this one first. It'll be like, oh, you hit 1.3 seconds. And that's the exact DT, like down to the nanosecond, or even beyond. So there's a new upper bound, but then this one also evaluates to the same bound. It could be excluded. Oh yeah. Okay. So yeah. Okay. So it could be excluded from the current iteration, but the next iteration where it transitions from a edge to a vertex, edge verts. What? Wait, real? Wait. Oh, okay. What is this? Edge, why? Wait. face? Does it know? Face N. Don't we have the face D as well? This is an ND. N delta pause. Why not use the face D? It's a face ND. Oh, this is a different N. It's doing the cross product. What the hell? Okay, so this is like your face. It's like it can be. Okay, so it's because the normal vector it's using is perpendicular to the face. So it's using the edge vertex positions dot producted with the perpendicular vector to get the D value. And it's different than a face D value. Okay, I see. I thought it was a mistake. Because like this stuff is only needed down here, but then it uses this value, which is based on this value, which is based on this value. I was like, oh, I could move this calculation down here, but no, I can't. I have to use this one. Okay, cool. Amazing. This is so amazing. So they completely changed these things, and now it's completely generic across different range types and queries, and it'll like monomorphize with the particular one. So cool. I wonder if it can like factor out the if statements and like monomorphize for the bound variant. That I hope it does. I guess it. I don't know. I don't know. Cool. Okay, range bounds. Yeah. Okay, crawl wants lower and upper bounds. So. Okay. So we. Oh. How do you swap this? Oh god. Okay, well now I have to think about. Oh look, it's these guys. Now I have to think about this. Yo. It shouldn't be too hard. Oh. How about that? Hi. I'm chewing. Genuous. Feeling genuous. This is like exactly what I needed. Is it a stroke of genius? Flash of genius? I was onto something with the range struct, but accepting any range and using the bounds representation. That's where it's at. Ratio 4. Oh. Do we gotta? Oh my god. Where's my function that does that? It's down at the bottom here. Who did GigaTime? Who did this? No. Model. Over. So we can have this function right here. And then it's a pub function. And face crawler uses it. And then very good, very good. And then start time Lee ratio. It does not need to be gigatime. It can be a not gigatime. Really, this is the reason why my come back to it every day strategy works, is because every once in a while, I'm just freaking a genius. It's fantastic. Okay, so we have bounds. It's not quite the thing. We have to be assigned like that. It has to be assigned to this precision. So that's why this one needs to do it. But start time never changes. So it's all good. Wasn't this... Why wasn't didn't I return a directed edge somewhere? What? Let me see. Contents. Oh, the flush face transfer. Out edge. So cool. That's so cool. Yeah, this guy. Brilliant. Okay. Small, small. Okay, it's fine. It's fine. We can map. It's okay. It'll work. It'll work. Trust. Start and it'll work. It'll work. It'll work. Yes. Okay. So map F. Map F. So okay, it's range dot start bound map. Boom F. Boom bound. Boom boom T. Boom boom. Boom T. Boom boom. Okay, got him, coach. Absolutely got him. And then this one is the into Giga Chad, for real. Yeah, range.endbound.map T into Giga time Giga T relative body dot time. Yeah. Okay. Oh, I need those functions. What? This totally should be not here. This should totally be in the face crawler. This is like a special case subset of the face crawler. Predict collision face out. Oh my god, Minkowski mesh, but it's not though. But it is. Predict collision out Minkowski mesh. Isn't that a mesh query? I guess it is. Cool. Okay, so this actually belongs on like mesh query. Okay. Ugh, okay. That makes sense. Self, you good? Start bound, M bound. Oh, T. Oh, T. Okay, so this is like, okay, okay, okay. So I actually want that. I don't actually care about anything else. I thinking me thinks that I want into bounds. I don't care about anything else. Okay, good. Start bound. Oh, lower bound. Upper bound. You know what? I could totally just use the same wording. Do that. Yes. So instead of lower bound, start bound. Like what? Uh-oh. Yes. Okay, so now I have crafted the type signature wrong. And it hates me, but that's okay because it was like a little bit wrong, and now it's not a little bit wrong. No need for this. Everybody happy. Yay. So I need these stupid functions. No, I need to move the code into the code so that it's the code. Unstable No. 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 Okay, that's a little bit. Rust. Oh, unlucky. Oh, it's not that far down. GitHub. No way. So we go like issue number 5,371,846. Oh. I'm in. Looks good to me. You go. March 3rd. The first one to ever see this or something. I mean, except for the guy who made it, but. No one has any comments. I guess it's like elsewhere. Into bounce trade. Whoa. Oh, I see. It's like Rust is so cool, man. Okay. So unlucky we can't actually do this. I have to change it all back. Unlucky, but it's okay. Oh my god. So range start bound, range end bound. Goo. Do we want to say like the same? Because it's like lower upper. I can just have it like this. Like it's not that big a deal. Like that. This is the only thing that happens. Cool. Okay. So negative time limit that's the upper bounds. So we're taking the lower bounds and making it negative. What if it's unbounded? Is that real? I think so. But it has to be a reference. Okay, range is actually not that good. Or not to the same standard as the excellent Rust standard library. The into bounds thing, that would fix it, but it is not stable yet. Or at least this one issue I'm having, I guess. Buh. I need to like... Is there a core convert function that I can just chuck in? Map core convert identity. So we don't want identity, we want freaking like deref. Oh, asref. Oh, that's cool. Okay. So we need T, and that's it. Yeah, because if it's a reference to time that has to be stored somewhere, and then it's like painful. Wait. Oh, I could totally, hold on. I could totally do map as ref. That would totally work. Okay. Let's do it. Let's do it. Lower bound. Oh, start bound. Wow. And then dot map. T negative T. No way. So this is actually the upper bound. Who did this? Start bound. Negative time limit. Yeah. So this is start bound. So this is upper bound. Left the stream on by accident. Oh, you? I'm like, what? I'm actively working. Okay, so here we go. Here we go. So I'm gonna name them correctly. So lower bound, upper bound, and then like this, and then like this. Swap and negate bounds to invert the field polarity. No, to do a time inversion. It just sounds like jargon. It basically is. Okay, so upper bound. So so we take the upper bound and we make it into the lower bound, and we take the lower bound and we make it to the upper bound. Oh, we have to do it at the same time because otherwise there's. So upper bound becomes lower bound becomes upper bound. Everybody very, very happy about this. And then now here, this is lower bound because it's based on the upper bound, which is the time limit. And this is as ref. And then everything works out. And then same deal here. See how this is like the first argument because it's the lower bound. And this is the second argument and it's the upper bound. Who did this? Okay, amazing. Incredible. Time inversion. And then that's the same thing. Time inversion. Yeah! And then everybody. Oh, I have to move this function. Because it doesn't belong here. Oh, self. Really, all of these junk belong on the mesh query trait. This junk is like, it's like an algorithm, you know, it's like an algorithm. You know, like an algorithm. Oh. Why am I? Oh, this is like 5, isn't it? N1. What's N? Goodness. Oh. 3. This is 4, bro. Okay. 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 Oof. So I need the goober functions from the face goober over here. I'm just gonna pub them. I don't care. To do move algorithm in here or something. Public. So now I can use. Buh. Okay. So I'm gonna use it. Is it? I don't know. It doesn't matter. I'm just gonna use it here. Okay. So this is the lower bound. Yoop. And this is the upper bound. And then we're still, uh-oh. Meh. I have to make it more generic. Oh my god. Okay, at least we don't need T anymore. Maybe we do. Oh my goodness. Okay, so this is den. Are we den? Den? I believe it's den. Denmol den nummol num. I don't know. Oh my god. Parody den parody. Okay. LHS parody. Expected den num. Who wrote den num? Who did this? Num den the what? This is the other way around. Den. Is it num mul den and den mul num? I don't know. Let's see if it is. No. Cannot behind a shared reference. That is so freaking ugly. Okay, moving on. Actually, it's the exact same trait bounds, isn't it? Oh dear. We just add in the RHS. And it is. Cool. Cool. Okay, so now we have an even more generic function. And this is definitely an inclusive bound, like everything else. And what the hell is going on here? Best. So it's in. Okay, so the output is different than the. So it's trying to return the wrong type. What would the initial value be? Ugh. I guess I could say best edge is the tuple. That would work. Should I also do directed edge? Nah, I'll do it right after. Okay. Okay, so the it will do like yeah, we'll go like this. We'll go like this. DT, and then boom, and then I'll just do it all at once. Directed edge, and we're gaming. Except we're not gaming. Aha! Found another bad boy. Okay, so start time is infinity. unbounded. And then included. I don't actually know. So would it be included? So you're crawling from infinity wait, what? I am confusion. Oh, min. Okay. I thought it was time max. I was like, why is it min? Or why is it max? How does that work? But it's min. Okay. So then, do we include this time? If you hit something at that time, okay, what the tarnation is this? So accurate. Okay, movement must escape the mesh forwards and backwards in time. Otherwise, the point is not inside the mesh. So, if you hit on the point, so that actually is like, does the surface of the mesh count as being in the mesh? So that's what that is. I'm gonna write that down because that's not obvious. Means that the surface of the mesh is inside the mesh. Included in the mesh. So I don't actually know if we care about that, but hot diggity damn. I wrote that code. I wrote those code. I ate those food. We're using bounds. Inclusive, exclusive. It's all good here. Wow. Directed edge. Baba B. It's not. Oh, it's unused. Okay. I don't think it's that important of a change. Okay, so this is physics. Use bounds. Very big change. But it should continue to pass all the tests. Yeah. Okay, this bug was on this guy. And we want to do this first. And test. Pass the test, pass the test, pass the test. I think I'm going to... Oh! I was about to say, I think I'm going to fail other tests. Wow. The type system absolutely carried me so hard. Wow. So I passed the new test and I don't fail any of the old tests. Wow. Let's go. Holy. Imagine. Is this all physics? Yeah. Wow. That's so gaming. Bug 7 fixed. Bug 7 fixed. Stream title win. Could not have seen that coming yesterday. Could not have seen that coming yesterday. Absolute W. Bug 7. Bug 7 is fixed. Predicted collisions could exceed the maximum representable times intersection, I guess. Representable time I-64. Minimum representable time I-64 values which were being used like they were infinity. Refactored face crawler to use explicit bounds to be able to represent unbounded time limits. And boom. Representable. Representable. Okay. Major W. Absolute gaming. I'm going to mention the added unit test in doop. I guess I can say the comment as well. To prove that it is fixed and prevent regressions in the future. predicted intersection times could exceed the maximum representable time values. Implicitly, infinity. To use explicit. You hear me say implicit, explicit on this stream so often. Anytime an implicit assumption becomes an explicit make it happen. Say it why. Say implicit assumption, explicit the opposite of assumption. Provide information. What the hell? How do you say, what's the opposite? Fact. Explicit fact. Yeah. Given. Yeah. Major gaming. All right. Question though. Does the game work? It could very well just like break, you know. ST cargo build release. So it should just work. It could be slower. It might also be faster though, because it can skip bounds tests when it's unbounded. Who knew? Oh my goodness. Okay. Arcane. Ooh, it runs. Ooh, does it crash? Do I fall through the ground? Did I fix any falling through the ground bugs? I wonder if... Well... Oh, talk. Nah. I thought I got it. Nice. Anytime I don't fall through the ground is a W. What if I just stop? Not bad. Yeah, I mean, it's not the fastest physics anyways. It's fast. It looks fast because it's doing almost nothing most of the time. It like grinds to a halt sometimes. So I wonder if this is fixed or if this is another bug. It could be the same type of like time overflow when you hit these just in the wrong way. And I might have fixed that going through the ground. All right, I'm just going to keep going through the map. Okay, it didn't happen there. I don't know if... Whoa! Ah! Wait, you can go across there? I thought you couldn't do that. There's an invisible wall. I'm going to beat this map and talk. This is worth celebrating. This is... Bug 7? Like, holy. I freaking fixed bug 7. Oops, I swore. Sorry. A little bit excited. Very excited. That's one less bug that'll bug me forever. All right, this didn't fall through. Okay, second try. It could very well be that it's fixed. It could also very well be that it's not fixed. Tree JPEG. Yeah. Dude, it might actually be fixed. It usually it happens by now. Bug down. Bug down. There's at least one bug gone. I don't know if it's the same bug. I'm about to find out. I'm about to find out if it's the bug. The bug. The bug did it. Get the bug. Oh. Oh. There's supposed to be water here. How will you render that? Shader. 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 Surely, right? Wow. It's probably going to be a while before we ever see water, unless someone else wants to work on the graphics. Because in my opinion, the physics is currently the most important stuff to work on. To me, like, graphics is like the least important right now. Like, you can see, so that's good enough for me. We can always do eye candy later, as long as you can play the game, right? But like as it is now, you can't really play the game. There's no leaderboard. There's no, like, you fall through the ground all the time in the physics. So that's why I have this list of 10 bugs. Is because there needs to be a game to be able to play the game. So that's what's going on. That's the idea. Nope. Parsing terrain data. I have seen someone make code. This works! Yes! I forgot I did that. That was on Friday, right? Oh no! No matter. Oh. No more infinite boost. Oh. Dude, it's so much better. Ah. Water is a necessity for some maps. So I don't have the water physics implemented either. I think I'm gonna need to have a fixed tick rate for the water. What if I could also have like a dynamic tick rate? That's an interesting idea. Huh. The faster you're moving, the higher the tick rate, so that it follows the differential curve. Huh. That's an interesting idea. That's totally viable because, dude, that's actually a sick idea. Dynamic tick rate water? Dude, it's deterministic but dynamic. Huh. I was thinking in such simple terms before. I can totally make it so that it like is really accurate and fast when it doesn't need to be accurate, or when it can skip calculations. I mean, it's not gonna out calculate the oh, that didn't make it. The physics calculations are always going to be more expensive than the water, unless you're going billion. But like, if you're going 1 billion units per second, the drag force will be insane. So in a very short time, you'll be going way, way slower. I have not fallen through there in any platforms. I wonder if that's it. I wonder if that was the last bug. I don't think so. I'm not confident about that. There's so many ways I can fail. And I have like 10 bugs written down. But we'll see. We'll go to the end of the talk map and see if bug 4 is the same bug. There's one of the bugs that I thought it was the same bug. I played one map that had a swimming segment. This map has a swimming segment. Yeah, I'll definitely need it for like water maps. I'm kind of glad I put it off though, because water dynamic tick rate is a great idea. Damn, damn. Oof. Yeah. Eyes don't fail me. Imagine like all the other bugs are just fixed. It was all just bounds. I think it was just that one minor case, and nothing else is fixed. That's how it usually goes. That's kind of the default for bug fixes. Is like you can like think it like feels possible that multiple bugs have the same root cause, but like more often than not, it's not the case. Could be caused by the same thing, but probably not. Damn. Can't do 3 there? Come on, man. Oh, dear. Yeah. 3, 3, 3, 3. Aha, I blinked. I lost it. Okay, this bug still exists. Fall Fu ground. Alright, can I... Nope. One day I'll be able to beat the whole map without flying. What about this? Cool. 654. That's the 11-minute time. All right, let's go talk. So what? I'm curious about this bug. There might be like multiple stuff underneath. It happens more at the end of the map. All right, I'm just gonna get into the map. I'll just do a full run. We're checking for bugs fixed. And one of the bugs which I wrote down, I am pretty sure that it's the same bug as the one I just fixed. 2 of the 10 bugs are actually the same one. Feels solid. Something just like is so nice, so cool about fixing a bug. The game feels more. It's like placebo, but like the game feels more solid. Like the objects exist in a more definite sense or something. What? I just went through it. Ah! Object solidness in tatters. Ah. Shambles. The other bugs. Other bugs. Round the corner. Whoa! Don't hit the corner. You jinxed it. Nice. God, the gain is ridiculous. I love this route. Look at this. So good. That's so fun. Oh. I was actually doing time. Nope. Doubt. Can you like skip hard? That bug still exists. So smooth. I hope it would be smooth at 2,000 frames per second. No. Well, that was a real physics debugging stream. If you've ever wondered what it looks like debugging a physics engine, that is an example. Pretty rare content. Even for me, who's written like 3 physics engines. To actually make progress is like pretty rare. And actually fix something. No! Yeah, I made cylinders as well. So, this part is way easier. You don't have to like slip through between the platforms. You can just kind of play it normally. Ooh. Oh. Nice. Middle. Nice. I wonder if there's a faster way. Nice. Nice. Can I do the climb? Here we go. Here we go. Oh, nope. Failed the first jump. Idiot. Okay, so let's see if this bug is fixed. I don't think it is. If I hit the side of a platform, I fall through the ground. No, it's not fixed. Unlucky. Very well could have been, because like you're like axis aligned, and so you could hit an edge case of the physics setup that has the same problem where like the transition exceeds. Well, I mean, it would have to be like a rotated thing. It would have to be like not quite axis aligned. It would have to be like ooh. That's not good. I have to be very close to being axis aligned. I do not know why that happened. I'm glad it doesn't happen often. Oh, yo! That was a sick route. Nah, I'm stupid. Oh, damn. Okay, at the very end of the map, there is potentially a duplicate bug of the bug I just fixed. I can't make that. And that is if I just stand still and jump and fall right here. I fell through the ground before. Do I still fall through the ground now? It was the same bug. I fixed the bug. 2 bugs down. They happen to be the same bug. Yeah. All right. Spell. Insane. How many bugs left? 1, 2, 3, 4, 5, 6. How many bugs identified? 1, 2. So this one, I'm gonna describe this more. Hitting the side of a crate on the last stage, falling through the ground with a G. So that's the one I just described, where like if I hit the side of it, I fall through the ground, and that still happens. The repeated activation, I've seen that happen. This one is BSP. Make sure I write that down. Oy, 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 oy. Damn. That's progress. It's real progress. Just come back to it every day. I knew it. It was just a mental block. And the idea I had this morning, I was like, wait, I could totally fix it. Damn, son. Go for these. Oh dear. His head does it way better. by Z. Yeah. Did we just listen to that song and I'm whistling and humming? Uh-oh. Oh dear. Come on. Bro. Okay. Let's see. We'll run the old physics test. I guess it'll pass. It'll just print nothing. Oh. I can squirm them all together. Right, I'm gonna want to actually let it print, let it cook. Yeah, so it just passes, no capture. It should look like very similar to the other one. Real crawl, miss, but it starts at face vert, just like the other one. And then true 2.0. Oh, I fixed the bug, man. I fixed it. The bug got fixed. Oh, got fixed. Sheesh. Man. I kind of want to find the other guy on here. Oh, crap. I do believe there's another time. Yeah, this guy. Min divided by 4. Boom. 2. Cool. I think those are the only ones, right? Continue. Oh. Oh. Huh. Well, that's not what I wanted. Interesting. I didn't expect that. That's okay. It's like 5 seconds. Continue rebase, and we want this one no matter what. Gaming, okay. So there's no difference, but right here, it just includes both of the things. Should be the same. Cool. I am extremely pleased. This is, without a doubt, a low-level physics fix. This is a physics bug which I had no chance of fixing just by chance. I had to create a test that makes the bug happen, watch the code while it happens, identify the issue, and then produce a fix for it, which was kind of involved, but not too big of a change. Or I was able to leverage some well-established types, I guess. that represent my data correctly. I didn't need to invent my own representations. It's convenient. Wow. Insane. Insane. Insane stuff. Absolutely insane stuff. That infinity did bother me when I wrote it, but I didn't expect it to be a problem, which like makes sense because like I wouldn't have wrote it if I expected it to be a problem. Just like edge case. It's just an edge case. There's an unbelievable amount of edge cases when you're writing a physics engine. Unfathomable. It's insane that my Roblox physics works so well. Let's go celebrate on Roblox. Oh hey, it's this video. I got distracted showing that off, and then still managed to get a bunch of work done. I was very hyped this morning. What the hell is this? Where Roblox just isn't showing. Jesus, like I just want to play B-Hop. I don't care about anything else. Sail on Fire. What a great song. Public server wasteland. I don't have a time. I guess not. Oh, really? Okay, there's totally a better way to do that. Oh, wow. Wow. Can you like, okay. You can totally hit that. Ah! Just hard. Oh. Yeah. I don't know. It's not. It's like a goofy map. There's a bunch of like tech in the middle. It's not the funnest to try to speedrun instead of try to complete. I guess it's a fun map to try to complete. But like speedrun is annoying. Sure. Uh-oh. Nice. How do you go fast? Oh, not like that. Oh. This song is really good. It's also really quiet. Annoying. Oh. I wonder what the WR looks like. You go like right here? I guess so. Nope. Oh, B-Hop and Surf. It's just a menace. Oh dear. Damn. Yeah. I'm kind of a no-fail completionist. If I don't love it, I don't finish. Yeah, this part's annoying as well. Oh, not that bad. What the hell? That used to be super hard. that was easy. All right, so what did I do? 234. Sucked up half. Cut that time in half I want. You're bored. I don't feel like grinding this map. Which is why it's not completed. That was a 4-minute song. All right. Well, I am extremely happy with that progress. That's the kind of progress that would. It's like hard steps. Have you heard of hard steps? It's like when you're talking about. It's like sci-fi. Well, not. It's like. What is it called? The paradox. The where are all the aliens? Fermi paradox. It's like, what if there is a really hard point in evolution where, like, if there's two species and they're like single cellular, the chances of them evolving to become multicellular is a hard step, and it's like vanishingly small probability, and it might happen in the next 10 years. It might not happen for 100 million years, and it's like a filter, a blocker that prevents life from becoming like intelligent life or something like that. So in the same way, these bugs in the physics engine are hard steps that prevent my toy game from becoming a real game that is actually worth playing. It might get done today, like it did. It might not get done for years. It's a hard step. But I got one today. It wasn't actually that crazy to wrap my head around. Some of them are like the multi-polygonal surface of the mesh has a micro unit concavity that breaks the face crawler algorithm in just the right way to. They can get very complicated. This one was easier than I expected, but still, it makes sense why I didn't find it. Because like I had just previously expressed the time. Wait, the cursor is offset. On my screen, I'm so distracted. On my screen, the cursor is right above the blinking. Like, I can't see the blinker because the cursor is above it. But on the stream, what? All right. Anyways, so I think I didn't think of it because I was using this syntax of the range. I was like, oh, I made it a range. Oh, that's so good. And I wasn't. I didn't take the idea to its logical conclusion because I thought I already had. And the logical conclusion was to use a trait impl of any range bounds, including unbounded, to allow you to unbound the collision predictions. And it can change the bounds as it's running. It's just the best. Amazing. Very, very good. And that was the fix, is that I was using the minimum representable value like infinity, but it wasn't actually infinity. So it just so happened that in some cases, infinity is compared against a value that's bigger than infinity. It's bigger than the maximum representable value because the type it's being compared against has a larger range of representable values. So in the solution is to allow the representation of unboundedness. So it's like actually representing infinity, but like not infinity. It's saying this is unbounded instead of this is the bound. And that's this type bound. It's unbounded, or it includes the bound, or it excludes the bounds. Painful? It was actually quite fun. Like Rust is amazing at that, and making you have the idea and then you just fix the red underlines until it compiles and runs perfectly. It was just a matter of fixing the old red underlines. This is the comment. I noted it here. This is ugly, but oh well. Lower bound, upper bound. It's a bound. It's a bound. Bound. I want to see the call site, actually. Let's go look at the call site. Isn't that cool? Where's the and then map? So this is doing like stuff. This must be rounded to avoid infinite loop and hitting the start zone. It might be that this is not needed anymore. Okay, what does it come out as? Ratio, and it goes into... Yeah. Let's try. I'll give it a shot. Temp. All right, so we got Minkowski and DT. And time is this guy. Oh, is this a named field? It is. Okay, let's see if this is an infinite loop. It might be fixed. I don't think it's fixed. I think it'll be an infinite loop. All I got to do is do a little figure eight at the start. And if I hit the start zone and the game crashes, then it's not fixed. But the like bounded, unbounded representation is like naturally excellent at like doing the right cutoff. All right, Arcane. All right, do I infinite loop? Whoa, that's actually surprising. I totally expected it to infinite loop there. Whoa. Oh, there it is. XD. Unlucky. Isn't this comment excellent? It just says what the bug is. This is just like A plus comment. Commenting code is like the best thing to do. Imagine if I did it. Imagine adding comments. Couldn't be me. Very nice, very nice. Wow. No clip. That's tempting. I'm gonna write that down for tomorrow. Thursday. No clip. But we'll see. Let's see. Is there anything else I can think of doing? Very pleasing. This is a very pleasing change. A bound. Obviously it's a bound. It's so obvious. Obviously. Actually, I could make it a little custom type here to allow a lower precision, because it's already switching. Super cool. I love how this code gets smaller. I guess this code gets bigger. This is so much more explicit as to what's going on here. So like this lower bound and upper bound in this function call, that makes sense. That's the lower bound, that's the upper bound. That's what the function arguments of fevcrawl are. But then the fact that they were inverted previously was not obvious. And then I explicitly say here, swap and negate to do a time inversion. It's inverted. See? Brilliant. Brilliant. To do, make better. Okay. So yes, so I was like, oh dude, I could use the range. And I just passed the range struct and then deconstruct it into the start and end. I didn't carry the idea to its logical conclusion where you could pass any range bounds and then it could possibly be unbounded even. Wow. You know what? The bug that I just ran into where you hit the start zone and it's infinite loop, I might be able to solve that with bounds if I think super carefully about it, but probably there will be some obscure bug that will make me solve it anyways. But Oh, there it is. So this is infinity. I was pretending that the minimum possible representation was infinity. And if I didn't shift it down a bit, it would overflow. So it was like a hack on top of a hack. And now, explicit. There is no hack. It is explicitly unbounded. Brilliant. Okay. I'm going to leave it there. Okay, well, so I'll see if I have the effort to stream again tomorrow and stretch and do no clip. No clip would be nice. But holy smokes, I did not expect to do a hard step today. Very cool. That's all from me. The end. Goodbye. Goodbye.